Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Google's interview with Laura Kastilani, product manager for the Pixel 10a, centers on a device that eliminates the camera bump while maintaining flagship performance and delivers satellite emergency features at $499. Her technical decisions expose assumptions about what budget hardware can achieve. Here's who is presenting these arguments. Laura Kastilani leads product management for Google's Pixel 10a. She directed the engineering effort to create a flush camera design and bring Satellite SOS capability to the A-series lineup. Her team's work directly tests whether premium features can scale to mid-tier pricing. A smartphone manufacturer claiming to eliminate the camera bump entirely while preserving flagship photo quality would typically be dismissed as physically impossible. The Pixel 10a, however, executes precisely this engineering outcome. Consider the established constraint in mobile optics. Superior sensors demand greater depth, which necessarily produces a protruding camera module. The industry has accepted this as an unavoidable trade-off for the past decade. Kastilani presents data that contradicts this accepted limitation. During the interview, she confirmed the Pixel 10 features a camera bar with 0mm of protrusion. She described this as a point of personal satisfaction, noting that among her friends' devices, hers is one of the few that lies completely flat. The technical execution required months of collaboration between industrial designers and engineers to achieve a flush rear panel without degrading optical performance. This outcome suggests the correlation between camera module size and image quality may be weaker than the industry has claimed. Google's implementation demonstrates that optical performance can be decoupled from physical bulk, producing a device with a minimalist profile that delivers contemporary imaging capabilities. Transitioning from hardware to software, the device introduces AI features that alter the mechanics of group photography. Standard practice treats a group photograph as a single temporal capture, requiring one person to remain outside the frame to operate the camera. Kastilani described a specific use case from her own family gatherings. With 20 extended family members, she typically serves as the photographer and therefore appears in none of the photos. Using the Add Me feature, she can now include herself in group shots. She also uses Best Take to correct instances where her toddler cousin looks away from the camera. She mentioned the satisfaction of revealing to her relatives that the device enabling these corrections costs $499. The Add Me and Auto Best Take features treat a photograph not as a frozen moment, but as a composite construction. Kastilani outlines scenarios where a family of 20 can have everyone present in the frame, or where a child's momentary distraction is corrected algorithmically. Her framework positions the perfect photo not as an exact record of what occurred, but as an optimized synthesis of who was present. By using AI to merge multiple temporal instances, the device changes the definition of a group photo from a single captured moment to a constructed representation of participants. This removes the constraint of the excluded photographer through computational means. Regarding market segmentation and safety infrastructure, the standard industry model reserves life-saving features and advanced connectivity for premium devices. Consumers purchasing mid-range phones typically accept reduced access to emergency systems. Kastilani shared a personal experience that informed her position on this feature. As an adult learning to snowboard, she once found herself alone on a black diamond run with unreliable cell reception. That experience reinforced her conviction that Satellite SOS should be accessible regardless of device price. She confirmed that Satellite SOS will be included in the $499 Pixel 10a. Her rationale centers on democratizing safety. If a user is lost in a remote area without signal, their ability to request emergency assistance should not depend on their hardware expenditure. This decision creates tension within the market hierarchy. By integrating satellite connectivity and emergency features into the A-series, Google is classifying safety as a baseline utility rather than a premium add-on. This raises the question, if a $499 device can communicate with satellites and enable off-grid rescue, what functional differentiation justifies higher price tiers? Extending this analysis to artificial intelligence, the prevailing narrative positions generative AI as a productivity tool for professional tasks such as coding or document creation. These applications are typically framed as desk-based activities. Kastilani recounted an incident while baking a Japanese cheesecake for her sister's birthday. The meringue collapsed unexpectedly. Rather than searching for text-based troubleshooting guides, she activated Gemini Live, directed her phone's camera at the bowl, and requested diagnostic assistance. The AI identified the chemical imbalance and recommended adding cream of tartar to stabilize the mixture, successfully salvaging the dessert. Her roommate witnessed this interaction and immediately expressed interest in acquiring a Pixel. This example positions AI as a real-time diagnostic assistant for chemical processes. Kastilani used Gemini Live to address a failed meringue by showing the AI the physical mixture. The system diagnosed the chemical issue and prescribed a specific corrective ingredient. This validates a functional shift in how large language models operate. The system is not merely processing text queries, it is analyzing visual and contextual data to solve a physical problem. The fact that this multimodal capability processing video and audio to resolve a cooking chemistry failure operates on a mid-tier device challenges assumptions about the computational requirements for advanced AI. It demonstrates that an AI superphone does not require flagship-level processing power. It requires sufficient intelligence to interpret context and provide actionable solutions. Finally, examining durability and sustainability, the standard assumption equates affordability with fragility. Lower-cost devices are typically constructed from cheaper materials with shorter lifespans. Kastilani stated that the Pixel 10a is the most durable A-series device yet, featuring reinforced cover glass and IP68 water and dust resistance, alongside 100% recycled packaging. This approach contradicts planned obsolescence strategies. By extending extreme battery saver mode from 100 to 120 hours and strengthening the physical construction, Google is engineering longevity into their entry-level product. The underlying logic is that budget consumers require greater durability, not less, because they are less likely to replace devices annually. This represents a structural inversion of how consumer electronics are typically tiered. Toward the conclusion of the interview, the discussion shifted to aesthetic choices, specifically the new berry color option. The host identified it as his personal favorite, prompting a brief exchange. Kastilani explained the strategy behind the color palette and shared an anecdote about inadvertently walking into Google's secure color lab while wearing a shade nearly identical to the upcoming color of the year. She clarified it was purely coincidental, offering a human moment within the technical discussion. For consumers currently evaluating device purchases, the critical action is reassessing actual requirements against this new baseline. When the budget option includes satellite emergency capability, flush camera design, and AI with multimodal diagnostic functionality, the relevant question shifts from what am I sacrificing by spending less to what additional value am I receiving by spending more. If you're interested in the video featured in this episode, click the link below to watch the original.